This section of the chapter 6 is very short actually, related with the derivative integration of the trigonometric functions. Actually, you know the derivative of trigonometric functions, so by considering this derivative, we can conclude the integral of the trigonometric functions. For example, what we know that derivative of the sine x is cosine x. So this implies indefinite integral of the cosine x dx is sine x plus c. And derivative of the cosine x is minus sine x. Directly from here we can say sine x is minus derivative of the cosine x. So integral of the sine x dx equals minus cosine x plus constant c. These are very clear. Maybe as an example we can say some things. For example, integral of the tangent can be discussed. So what is the integral of the tangent x dx? You know the substitution rule. So by using substitution rule you can calculate. Tangent is sine x over cosine x. So by saying cosine x is u, let cosine x be u. So this implies minus sine x dx du. Okay. So this expression, sine x times dx, will be minus du. So as a result, this is integration minus du over u. So this is ln u minus ln absolute value u plus c. U is cosine x, so minus ln absolute value cosine x plus c. By using properties of the logarithmic functions, we can consider this minus 1 as a power of the cosine x. So this is ln absolute value cosine x to power minus 1 plus c. Cosine x minus 1, cosine x to power minus 1 is 1 over cosine x. So this is secant x. So this is ln absolute value secant x plus c. This is the derivative of the tangent. By the same way, you can calculate derivative of the cotangent x function, and you may calculate the some other integral for the. Sorry, you can calculate integral of the cotangent x function, and you may calculate by using the substitution techniques integral of the some trigonometric functions. In this section also you can find an example, application example. If you look to your textbook, in the problem solving hour, I will solve that question.